Hi, okay, welcome to session 10. We've got two different graphs, ways to represent data in today's session. So it may be that you choose to do it in two sessions. It may be that you choose to do it all in one go. Entirely your decision, of course. We've got the recap. Again, I have done that so you can print it. I will disappear in a minute so that I can zoom in and allow you a bigger kind of picture of what's on there. If you can obviously work your way through that and then mark your work, then we'll be ready to move on into the new learning. Okay, so there we go. I will scroll slowly through. Okay, so hopefully you're taking the right amount of time, pausing and playing in the right way in order to be able to work on that recap and mark. And hopefully it's going well. That repetition should now be making you feel a lot more confident than where you were at the beginning of the course. And obviously, if you're looking things up, that's absolutely fine. It does take time for things to really sink in and come back naturally. It will happen. It's just practice, 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 isn't it? Okay, so we're doing two today. We're doing frequency polygons and we are doing scatter diagrams, and we are doing them because they are incredibly common. So there's a high chance one of them, or possibly even both, are going to come up across those three papers. So we want to be confident when it comes to being asked to draw either a frequency polygon or a scatter diagram. Scatter diagrams are more likely to be interpreting questions, so we'll be looking at that. So frequency polygons, that is just a fancy mathematical language for a straight line graph. All you are actually going to be doing is drawing a straight line graph, which is what a polygon actually means. So a polygon are straight edge shapes. So a triangle and a square, a hexagon, octagon, it doesn't matter. As long as there's no curves, if it's a shape made of straight edges, it's called a polygon. So this frequency polygon gets its name because it uses straight edges. So that's why we've got the language we've got. It is incredibly simple. You will be given a table, and most likely one with a class width. So when I look at this table, it's telling me that I've got 12 numbers that lie between 30 and 40, but I don't know what they are. So I am going to need to represent this class width as fairly as possible. You've heard this before, haven't you? This is exactly the same as when we're estimating the mean. So I am going to be using the midpoint to help me fairly represent this class width. Now, to plot a line graph, I am going to need coordinates. If I am going to plot a graph, let's just make one up. There it is. And create the straight edges that it's supposed to have. I can only get to that stage if I have got coordinates. So from the table, I have to get that information. So we've already spoken about using the midpoint. So 35 is going to be a coordinate that I use. That is going to go with 12, my frequency, and that is the first coordinate that I would plot. So frequency is always along that y-axis, and our x-axis is our class width. all of that would be labeled for you, but it's really important to check in with your label and your table just to make sure you are plotting things on the right lines. So the 35 is midway between 30 and 40, and I'm plotting it on the number 12. Now you must always check your scales really carefully. If I just say, okay, midpoint is, I'll use my light, midpoint is here, there's 10, 11, 12, and I plot it here, that would be wrong, because if I kept counting, that's 12, 13, 14, that would make that line there 15, but it is actually 20. So I must really pay attention to my scale. This scale is going up 2 each time, so 12, 14, 16, 18, 20. So my 12 is actually the first line. So those are the types of details that you must be checking in with when you are plotting these coordinates. So the next one is going to be 45 with 14. So 45 and 14 is there. I've then got 55 and 10. So 55 and 10 is there. And then 65 and 4. 65 and 4 is there. So once I've got those plotted, I then draw with my ruler and my pencil, and bearing in mind I'm using a bit of software, so if it goes off slightly, I do apologize, but we want to draw a perfectly straight line from one cross to the other. So there to there, and then there to there. No wibbly lines, just really neat, straight edges. And that is it. That is a frequency polygon done. Now, what we do need to be really careful of is putting any extra detail in. So I see students do this, brilliant. Then I see them lose a mark because they want to draw a line from the 0 point. They want to do that. It feels right. It feels like it's something they should do. It's absolutely wrong. That point in the corner was never plotted by us, so it can't be used. The other error that I sometimes see, not as often, but it does happen, is joining up the last and the first one like that. That creates a polygon. So it's not a really stupid thing to want to do when it's called a frequency polygon, but it's not an accurate picture of the graph that we're trying to create. So we can't include that either. So it is literally the points you put on the graph that you draw to. And that is a frequency polygon. There really is nothing more to it than that. Okay, so you have got this available to print. If you can't print, then unfortunately you are going to be slowed up whilst you set up your graphs, which is fine. It just means that your session is going to take a little bit longer than you might like. So what I'd like you to do is either obviously create this question on the paper that you're using or print off what I've given you. And I'd like you to draw the frequency polygon for this particular question. So pause and hit play when you're ready. Okay, so there's the answer to your practice one. The midpoints were 3.5, 4.5, and so on this time. Frequencies stayed the same, and you literally just plot through those coordinates that you've drawn. So hopefully that went well. And that's it. There's nothing really more to say. It's just a case of knowing the language and what it is they want you to draw and knowing to take the midpoint from the table. So you have got a practice question underneath on that same sheet. So you've got a practice question here. And then you've got 2 more questions to have a go at. And then we're moving into scatter diagrams. Obviously, if you want to take a break and come back and do the scatter diagrams a little bit later, that's fine, because I'm sure the recap took a little bit of time as well. You've got to do this at your pace and what works for you. So there's a practice question. I'm going to bring the other questions up as well, just in case you don't have those printables, and that way you can just copy it down from the screen and then the answers will come up. Okay, so there's one. That's the next one. Again, just pause and press play when you want to see the next one. And the third one. And these are your answers. Now that was the example we did. Whoops, there we go. That was your first practice question. That was your second. And your third one is there. Okay. Well, hopefully that went really well. So let's resize the paper. Okay, so we're going to move into scatter diagrams. Now, scatter diagrams are actually quite special. They are the only graph that will actually look at two pieces of data at the same time. And it will enable people to, you know, if they're conducting an experiment, if they want to see the effect maybe a new medicine is having on a certain symptom, then they can take those two different things and plot it to see what kind of relationship there is between those two different bits of data. So I shall give you the background of scatter diagrams and kind of how they work, and then we will get stuck into how they look in the exam and what's expected of you when you come to having to answer them. So as I said, a scatter diagram is exactly what it sounds like, okay? So you will have a graph. So let's just say you've got this L shape, and you will literally have a scatter of crosses. And if there is a relationship, then you can see a trend in those crosses. So if you look at what I've just drawn there, you can see that they are they're kind of moving in an upwards direction. So if I was to take this one, for example, the coordinate of that has come from this point here on the x-axis and this point here on the x-axis. If I was to take this one, for example, that one has come from this point here and from this point here. So what that graph is actually doing is, as the crosses are moving up and across, they're getting bigger and bigger and bigger. So as my x-axis grows, my y-axis grows. A condition where that might happen is if you were to measure the height of someone and maybe their shoe size. The taller the person is, generally speaking, the bigger the shoe size they take. So you have this, as they get taller, their shoes get bigger, and you get them, they're both growing together at the same time. And that creates a scatter where you have what we call a positive correlation. Okay, so this is a positive because it's going up together at the same time, positive correlation. And that might be one of the first questions that they ask you in the exam. Describe the relationship. You must use the word correlation if they don't. If they just say, you know, describe the correlation, you'll just write positive. But if they say describe the relationship, then you've got two possible ways to answer the question. You can either say it's a positive correlation, or you can say the taller the person, the bigger the shoe size. And that is perfectly acceptable. So you either describe the story the graph has given you, or you mention its correlation. So that is an example of a positive correlation. So an example of a negative correlation, so we'll just get an L in here, is when the opposite is happening and we end up with this scatter of a downward trend. And we would call that negative correlation. And what you can see here, so again, if I do what I did before, if I take a good look at that cross there, it's coming from quite a high number on the y-axis, but it's coming from a pretty low one on the x. And then if I go to the other extreme here, that is quite high on the X and relatively low. So as one's getting higher, the other one's getting lower. So they're in kind of opposite movements to each other. And that's creating this negative trend. So an example of that could be the amount of alcohol I drink and my reaction time, let's say. So when I haven't had very much to drink, my reaction time's really good. When I've had maybe 2 or 3 glasses of wine, my reaction time is a lot slower. Okay, and that is a trend that is proven to be true. You can get no correlation, which I will show you. It's very rare that you would ever see a no correlation situation on an exam paper, because once there's no relationship, there's nothing more to say. So if you have just a scatter where there's clearly no up, there's no down, it's not positive, it's not negative, it's just a proper scatter of data, it's showing that there is either not enough evidence, not enough data pulled from an experiment yet to show that a correlation could be present, or you simply are never going to get there. You're just not going to find one. The sort of, the idea that I came up with an example here was to say somebody's shoe size and the distance they travel to work. You know, there's just not going to be a correlation at all, is it? You know, it's not, you know, people with big feet work further away than people with small feet. It's never going to have a relationship. So you've got this no correlation situation. So that's the first thing to know about scatter diagrams. They are about 2 things and about whether or not there's a relationship between them. And that relationship can be positive or negative. And we need that language if we're going to answer scatter diagram questions properly. So quite often in an exam, you are given the scatter diagram. So there's a scatter diagram that's been given. Sometimes you're asked to plot an extra couple of coordinates, and if you are, then you would just do that. But most commonly, you're asked about the relationship. So here I've just said, what is the correlation? And the correlation to this is negative. So I would write in negative. The next most common question that you're asked is to use your graph to predict how much petrol the tank has used after 30 miles. So my story is all about the amount of petrol in the tank as I'm driving. And obviously the petrol is getting less and less and less as the miles are going up and up and up and up. Now, in order to predict, you need to put a line of best fit on. Now, this is where I've struggled with the software that I'm using because it wants to ping around all over the place. So I've kind of pre-prepared my line over here and I'm going to drag it in. But before I do, what we want to do when we're drawing a line of best fits, we want to get our ruler and we want to try and get it so it's literally, I hold my ruler up on its edge and then I kind of look over the top of it and I see how many crosses I've got above it and below it. And what I'm trying to do is get them as close to the ruler's edge as I possibly can so that I've got like this evenness look about it. So if I put my line in about here, that's a pretty good line of best fit. I kind of see it like a magnetic line. I want to try and get those X's as close as I can. So this one's quite close. That one's a little bit further away. This one's bang on. Then they're about even. That one's a little bit further away, but then that one's a little bit closer, which kind of balances what's happened up there. They're about the same. And everybody's line of best fit is going to just be maybe slightly out, maybe 1 millimeter this way or 1 millimeter that way, maybe 2 millimeters. It's not going to be massively different, but they might be slightly different. So when it comes to answers, they can sometimes give a range and sort of say an answer between this and this would work for anybody's line. As I've gone through this, I've done it as a kind of set standard number. But what you can do is if you're like 1 away or 2 away, you can be sure that you've done pretty much the right thing, okay? You get 1 mark for putting that line of best fit in. So don't forget to do it. It's really, really important. You will lose the mark if all you do is write an answer. So I've got my line hugging the crosses as close to it as I can get. I need to predict how much petrol is in the tank after 30 miles. So I'm going to go to the miles axis, which is this one. I'm going to go to where the 30 is, and I am going to mark on my graph so my examiner can see exactly what I'm up to. I'm going to follow that 30 line up until I hit the blue line. And then I'm going to come across. This is working out well for me, isn't it? Because it's coming out bang on 40. So my answer is 40 litres. And I've answered it. Okay, so that's what we're going to practice in the session. We're going to practice recognizing the correlation, putting on a line of best fit, and making predictions. And just be mindful of your scales. You need to be as accurate as you can be coming along those lines. Okay, so we've got one here for you to practice. So this is your practice question, which is in your printed document. If you can't print, then you are going to struggle with this particularly. You can do your best to do an estimated, like sketch that out and try and get it as accurate as you can, but it is going to be a little bit harder for you if you can't print this. So press pause and hit play when you're ready. Okay, now here's the answers. I did them ahead because of the straight line that can go a bit array for me. Okay, now yours might be at a slightly different angle because of this big sort of gap here. You may have come up a little bit more at a slight angle. These were a bit tighter, so I did a bit more concentrating here with my line to get those tight and just did my best in the hope that they would go through the middle as best as possible. So it's a positive correlation because we've got that upward trend. We had to go along at 48 from science. So I went to 48 here, hit my line, came down, and I got 63. Now, again, if your angle of your line is slightly different, then you might have something like 62, 64. And if you've got something like that, absolutely fine. But if you are massively different, then the chances is your line of best fit isn't quite in its best position. So really watch for that. And that's it. That's what we're going to do in our practice. So we've got this question here. Again, like I say, if you can't print, you are going to struggle a little bit with this. You can do your best, obviously, to copy them out. And I will zoom in just in case. But you've got 4 questions. So you've got these 2 and another 2, and then the answers will come up. So I will obviously expand these out and go through them slowly so you can pause and play if you do need to copy, and then obviously pause and play for the answers. And then that's the end of this session. So well done. It's quite a lot in one session, 2 different topics covered. Hopefully it has gone well, and I will see you next session. Okay, so question 1. And that's 2. That's 3. And that's 4. And now the answers. 1,